Welcome to the Triple Physics Paper 2 Forces and Pressure revision presentation. A force can make things turn or rotate. Now we can measure how much turning effect a force will give you, and the turning effect of a force is called its moment. If you want to increase the moment, how much turn a force gives you, you've two options. Increase the force, so if you push or pull harder, you'll get a greater moment. But you can also increase the distance of the force from the pivot. That gives us a calculation to work out the moment of a force. The moment of a force is equal to the size of the force in newtons multiplied by the distance of the force from the pivot. The force measured in newtons, the distance measured in meters, gives you the moment unit of Newton meters. You may see Newton centimeters, but always calculate in Newton meters if you're unsure. M equals F times D, my friendly dog. Where a system is balanced or not rotating, the resultant moment is zero. In other words, the clockwise moments, wanting to turn the object in one direction, are equal to the clockwise moments, wanting to turn in the opposite direction. So zero resultant moment means the system is balanced, or you may use the term it is in equilibrium. You can use this then to calculate the size of the force needed to keep a system in equilibrium, or the distance to put a force at to keep a system in equilibrium. If you want, you can pause the video, try and work out the size of force F, and work out what distance you need to put the 15 Newton force at to keep the system in equilibrium. Using moments on a lever like this means that you're sending the force from one end of the lever to the other end, transmitting that force. And if you use a lever which is longer on one end than the other, that acts as a force multiplier. In other words, the force you put in is smaller than the force you get out, or the output force is greater than the input force. Another way of sending a force or a moment is by using gears. Gears are just wheels with a number of teeth cut into the side of them. If you use a smaller gear wheel to be driven by a larger gear wheel, the smaller one will turn faster, and the gears will always turn in opposite directions. We can also think about how spread out a force is. Pressure gives you a measure of how much a force is spread out over an area. So the calculation for pressure is force divided by area. Force in newtons, area in meters squared, which gives you the unit for pressure as pascals or newtons per meter squared. Particles in a fluid can create a pressure. Fluids are liquids and gases called fluids because they can flow. The particles aren't stuck in one spot. And as the particles move around, they'll hit the side of the container they're in. That overall produces a force, and we say the force is at right angles or perpendicular to the surface they're hitting. The force from the particles divided by the area it's spread over gives you the pressure from that gas or the pressure from that liquid. If you are at a certain depth in a liquid or a gas, you can calculate the pressure. The only thing that makes a difference is the depth you're at or the height of the fluid above you. The calculation says that the pressure is equal to the density of the fluid multiplied by the strength of gravity multiplied by the height of the liquid or gas above you. You don't need to learn this equation. It is given on the formula sheet. When you put an object in a fluid, because of that calculation, because the bottom of it is deeper than the top of it, there's more fluid above it. So the bottom of an object feels a greater pressure than the top of an object. Now the resultant force from those two pressures is called the upthrust. So the larger force at the top and the smaller force at the bottom give an overall upwards force called the upthrust. If the upthrust is the same as the weight of the object, it floats. But if the upthrust is less than the weight, air is a fluid, so it creates a pressure as well. The air molecules move around and collide with objects. And so the higher you go up, the less and less and less air there is piled on top of you. So air pressure decreases as we get higher and higher. Now it should decrease at a steady rate as the height gets less and less and less of the fluid above you. Then the pressure should decrease at a steady rate. But actually it decreases a lot more than we expect because the air is a lot less dense when we go up, so there are fewer particles colliding with you. So as you get higher up through our atmosphere, the air pressure decreases because there are fewer particles above you and because the air is less dense.